Okay, so we are working our way through Module 9. So hopefully you had a good rest over spring break, and now it's time to push on through and hopefully finish strong. So what we're going to look at now, so we kind of are finished with the rocks and minerals, that kind of stuff. Now, of course, we'll refer back to those things when we're talking about other geological topics. But for now, we're going to talk a little bit about structures and some earthquakes, and then we'll get into some processes, rivers and glaciers and deserts, how they form and how we can recognize them in the rock record. But for now, we want to talk about what's called structural geology. And this is the idea that, and of course, it's related to everything we've done previously, that rocks can be placed under stress. And we know that because of plate tectonics. And so what can happen when we apply stress to the rocks is really two basic things. One is they can break, and we kind of refer to those as earthquakes. And when the rocks are broken, and we see that in the field, we refer to that as a fault, kind of what you see in this image here. But the rocks can also bend. And it does sound odd that rocks can fold or bend, and that's our other kind of result from the stress. But this is happening deep in the earth. So the idea is that rocks near the surface are cold and brittle, and they break when undergoing stress, while rocks that are buried deep are hotter, a little warmer, and they're easier to deform without breaking, and they can bend. It's obviously a slow process. It takes millions of years potentially, but we can get these folds. And then, as always, how do we get stuff buried deep in the earth to the surface? We uplift and we erode the material that's on top of it, and voila, we have it at the surface. So that's what we're going to focus on today, or this module anyway. And so for the lecture, I've kind of got three, as you can see, little videos that cover the structural PowerPoint. So the structures in general, and then focus on identifying folds, because of course, in geology, like many sciences, we want to label things. We want to say, hey, that's an anticline. And you'll say, what the hell is that? And hopefully after watching the video, you'll be like, oh, I know what that is. Or we'll look at a fault and say, hey, that's a normal fault or a reverse fault. So it's going to focus on the folds in this video and the faults in this video. And of course, that's the main kind of topic today, and that's what the quiz will be over. There is something that we reference when we talk about structures, and that is what's called the strike and dip. And so it's a measurement you take with a special compass that tells you the orientation of layers, because sometimes when you break the rocks or bend the rocks, they're no longer flat, right? The deal is that when rocks were deposited, at least sedimentary rocks and some volcanic rocks, that they're flat. And if they're not flat, we can make the observation and interpretation that something happened here. We did something to the rocks. And so we want to be able to describe its orientation. That's what a strike and dip does. Its orientation in space. Is it steeply dipping or gently dipping? And then what direction is that? So we can do that with what's called a strike and dip, which is described in here. But this little video, if strike and dip was like, man, that was crazy difficult to understand, this video will hopefully help you with that. So you can just take a look at that to help you with the strike and dip concept. And then, as always, we have a couple additional things to do. The article is talking about some other structures, some brittle deformations. So mostly talking about faults, but also talking about what are called joints and veins. So you can look at that and take the quiz. And then the video is an Earth Revealed, talking about geologic structures, why we look at structure, why do we care? Well, certainly earthquakes are a problem for society. It'd be nice to know where they're happening and if they're going to happen again. But a lot of times we find valuable resources at folds or faults. So oil, gas, things like that kind of accumulate there. So that's useful to understand the structures. So the videos here, we can take a look at that. And then finally, for the homework here, what I'm going to have you do, excuse me, is look at these block diagrams. And because you've learned all this cool information, I want you to be able to identify the proper fault name. And so if you read the instructions, right, there's three fault names we're looking for, right? We're looking for, it's a reverse, it's a normal, or it's a strike slip, and each has a specific stress type associated with it. So make sure you are aware of the view. A cross-section view is a side view. A map view is looking down on the earth. It matters when you're identifying fault types. So go ahead and work your way through here and answer that. And then we'll have a fold diagram. So once again, because you've learned all this cool information, depending on the view, remember, map view is looking down. This is a strike and dip symbol, so you'll be introduced to that. Ages of the rocks, remember, 1 is the oldest, okay? So ages of the rocks can be used to identify a fold type. And then remember, cross-section is side view, map view is looking down on the earth. So then you can go ahead and answer those questions. And that's what you'll do for the homework. So that's what we got this week. And of course, we always have a lab. The lab is set up the same way it's always been set up. And so you can go ahead and work your way through the lab. It is on structural geology, so it should complement the information that you're getting here. And I think that's true. Is that true? Yes, it is. Structural geology. Got it. Okay, just had to make sure we're doing structural geology lab. All right. So as always, if you have any questions, comments, concerns, please don't hesitate to ask and have fun.